Okay, it looks like it's the top of the hour, and we have a good number of people just on. And this is your co-chair, Joel Halpern. Luigi, you want to get us started?
Okay, so welcome everybody. This is the LISP working group. What you see on the screen, and now in full screen, is the not well that you are deemed to have read during the registration process. We will have a short session today, only 50 minutes. Okay, these are the usual pointers, including the one to this session. Everything is virtual this time. This is a very short update. The real update is GPE. He's forwarding, moving toward publication. About the BIS documents, well, Albert will give us a quick update, which leads us to the agenda. So actually, just for clarity, there was no call for agenda items this time because we thought that the interim meeting was pretty good, because it was short and focused on few items. So we decided to keep it in that way. So we will have just part of the session. We will talk about the non-traversal problem, and the other part is the LISP Uberlay. Okay, just after the update on the BIS documents by Albert. Okay, so I will move forward and go directly to the slides. I have to stop. Full screen, and you should see the.
There we are.
Yeah. And Albert is ready.
Yeah.
You may want to make that screen bigger though,
yeah.
Luigi. There you are.
See it bigger?
And,
perfect.
Yep, perfect. And just so folks know, I will be monitoring the chat and monitoring the queue. And when people want to talk, I will enable you and tell you you're enabled.
Great, thanks. So hello. So this is the usual update on the documents. I will be super brief because, as Luigi pointed out, I think it's worth to put time into the discussion. So next slide, please. So I just posted the two new versions a few hours ago. So this is number 33 for the data plane and number 28 for the control plane. And this is addressing the new ILG comments and discuss that we have received, which were not a bunch of them. They were, I will say, quite minor. So next slide. So this is a summary of the changes for the data plane. So I have added a section stating the guidelines for deployment over the public internet, which means that in the data plane, the N, L, E, and B bits needs to be 0 because you must not. So we have elevated from should not to must not use locator status bits, econons, gleaning, map versioning, and instead you should rely on control plane mechanism. This is per request of the reviewers. Then I have also removed that you can change the list nonce when encapsulating to the same ETR, because before that it was written that you could use it for a few seconds, and this is not secure. Also, the stateful MTU algorithm only now works for IPv4 and not for IPv6. And also a recommendation to consider the IPv6 flow label for load balancing hashing when you hash towards different when you load balance towards different locators. And then a bunch of editorial and minor updates. So next slide, please. So this is for the control plane. Similarly to data plane, we have added a section stating that when communicating over the public internet, LISPsec must be implemented. So you need to set the S bit on map reply, map register, and ECM. And also by request from the reviewers that we should use the stronger HMAC and KDF function. And in those cases must not use an algorithm that does not use a KDF function. And then a bunch of minor editorial updates. So that's it from my side. I don't know if there is any comment or question.
Any comments from the floor?
Go ahead, Fabio.
No, just wanted to maybe add about LISP-GPE. We are also done with all the comments, I believe. The last one were from Magnus and Roman that have been addressed in the version published on Monday. So I think all the comments that were out are addressed, and I think Magnus has acknowledged that he's fine with the latest version.
Yep. Magnus confirmed that in conversation with me.
Good.
Okay.
Thank you, Fabio.
Okay, thanks.
Thank you, Alberto. Dino.
Hello?
Hello, Dino. You really should have used the Q button, but okay.
You can hear me though, right?
Yeah, we can hear you.
Okay. Okay, I'm just going to give a pretty brief presentation on the Lispers.net NAT traversal. How much time do I have?
You have 20 minutes if we split half and half between you and Victor. So 20 minutes.
20 minutes for presentation and discussion.
And discussion, yes, and discussion. So
that I have to share with Victor. Is that correct? So I have
no.
Yeah, you have a slot of 20 minutes, which includes the question, the discussion.
Okay, got it. Okay, so this is a NAT implementation that I've done. Next slide. The purpose of I wrote a small draft, and the purpose of the draft is to describe a simple version of NAT traversal, and it's based on a subset of procedures and message formats from the Lisp NAT traversal that Vina and company. There's many authors on it. Wrote many years ago. And the Lispers.net deployment's been around since 2014, and it's been used pretty heavily and daily. It's still quite a bit in use. Next slide. Okay, so the requirements to do adequate NAT traversal is to have an XCTR function according to 6830 bis and 33 bis when it sits behind a NAT device. So the requirements that I set out that I thought was important for robust deployments was to have an XTR function when it sits between itself and the infrastructure via a NAT device that can be directly connected to it or multiple hops away. The XTR must function when it runs in a Lisp mobile node, in other words, running not just as a router type device, but when it's running in a host in either bare metal form on a mobile device, in a VM or a container, like I said, logically or physically. The XTR must function when it resides behind multiple NAT devices between itself and the RTR. So double and triple NATs are kind of the norm today on the internet, so it must function in that sort of scenario as well. Usually when an XTR is like behind a home gateway, it's behind the NAT that it's at its house. And if it needs to talk to an RTR that's in a cloud provider, it's yet behind another. The RTR is behind a NAT that's being protecting the cloud infrastructure. So the double NAT is quite a popular deployment scenario. The XTR must function when it is multi-home between different NAT devices. So I've done, my house has two internet connections, or at least it did. One was cable and one was DSL, and I would have NAT devices from each of those service providers and had an XTR that was dual homed Ethernet to each one of those. Very much like a single site router would be dual home to different service providers on a Lisp site, but then of course there's NATs connecting these. Also, RTRs and PXTRs must function behind NATs because of how cloud deployment has developed over the last decade or so. The Lisp Internet Groper or Lisp LIG function must send requests when it's behind a NAT, regardless if it's a Lisp XTR or not. The tool is an independent tool that can run anywhere. That needs to be able to work as well. And of course, we want IPv4 unicast and multicast, as well as IPv6 unicast and multicast packets to run when they're being sent from EIDs to EIDs. And not to mention, also to mention that if I'm an EID and I want to talk to a non-Lisp site, that needs to work as well. And that usually happens with either using Lisp NAT, which is another function of NAT, or using PXTR functionality that's in the inner working draft. And didn't see a need to support IPv6 RLOCs because typically IPv6 isn't NATed in most of the scenarios that I've seen. So next slide. Okay, so this is just a simple protocol exchange sequence before we look at a visual of it. Basically, when an XDR comes up, it periodically will send an info request message. That info request is defined in the NAT traversal internet draft that's been sitting as an individual contribution for a while. It sends the info request to a destination port of 4342 to the map server IP address. This is so the map server can reply with a list of RTRs in an info reply message. The list of RTRs is usually a policy parameter and configuration information on the map servers that this XTR is using. Once the list of RTRs is returned from the map server, the XTR then sends an info request to the destination port 4341 to each RTR. This is probably the most critical part of the NAT traversal because this allows the NAT to install forwarding entries or access list entries, whatever you want to say. So when an RTR then has to forward packets to the XTR through the NAT, that it would send packets from port 4341, the source port of 4341, and the destination port would be the translated port that was translated by the NAT device sitting in between. So remote RTRs that want to send to EIDs behind this XTR that's behind the NAT encapsulate to RTRs, and the RTRs decap and re-encap so they can send to the XTR's translated RLOC. So the RTRs encapsulate to the translated address and port that would be in the destination address field of the IP header, as well as the destination port of the outer UDP header. And then XTRs will map register the list of RTRs they were given, as well as translated RLOCs. It knows what its translated RLOCs are from the info reply that comes back from the map server and the port number. That is in the payload of the info reply, so it knows how to register the translated address information. And then XTRs for sending packets. Everything we explained so far is so packets can come to the XTR from the infrastructure into the private area behind the NAT. When an XTR wants to send packets the other way, it just has a default set of map cache entries where it just simply encapsulates to RTRs. But the XTRs can encapsulate to any other devices anywhere else if they are not sitting behind NATs. So they could have either shortcut entries or direct entries to those non-NAT XTRs, as I indicated on the last bullet. Okay, let's go to this slide, the next slide, I'm sorry. So let's look at a time sequence here, basically explaining, but now you can see it in visual form. I'm explaining everything I did on the last slide. Let's look at the white lines first, because that's basically the control traffic. You see the XTR on the bottom. If it wants to receive packets for EID1, how do external systems send packets to EID1 when it's sitting behind that NAT device? And like I said, what it does periodically, I have a 15-second timer that now sends info requests to 4342 periodically. That happens at time 1. It sends it to the mapping system. When I say it sends it to the mapping system, it's configured set of map servers that it's registering to is where the info request is sent. So multiple info requests could be sent to multiple map servers. The map server, like I said, is configured. If you, I don't know if you could, you can't see my pointer as I'm moving it. Is that true? Can you see me moving it?
No.
Correct. We can,
No.
because Luigi is sharing, nobody can see your pointer.
Yeah.
Ah, okay. Okay. So if you see the right under the mapping system, I say the map server RTR list is ARTR1, ARTR2, and ARTR3. That's just a configured list of what it's going to return in info replies. So at time 2 in white, you see that list being returned. At time 3, then, basically what the XTR has is a list of RTRs as well as the translated information. So now it can register EID1 with 4 locators in the locator set, or the RLOC set. The 3 RTRs, as you see, that I set to priority 254 because that's a way to identify RTRs that are in the list versus translated RLOCs. And the last RLOC that you see there, called TRLOC and TRLOC, is the translated RLOC only, not the port number. The port number is learned by the RTR when the info requests are sent to 4341, which is the other 3 in the bottom left-hand corner at time 3 there. Okay, so the mapping system obviously stores what's being registered. You see that on the upper right-hand side of the diagram. So the info requests then are sent to 4341, and you see the 3 white arrows going from the XTR to RTR1, RTR2, and RTR3. That's to allow the NAT to install state, so those guys can encapsulate to the XTR behind the NAT, and that happens at those white lines right there. Now let's use an example where EID3 wants to send a packet to EID1. So that EID3 is an XTR, and I show it there that it's not behind a NAT. It's just a remote ITR out on the internet somewhere that's part of the overlay. And when it wants to be able to send to EID1 and doesn't have a map cache entry, what it does is it looks up EID1 in the mapping system. So it sends a map request to the mapping system. What the map server will do, the top number 4, returns a list of RTRs and does not return the translated RLOC. So what I call this is the map servers return a partial RLOC set depending on who's requesting. Since XTR is not the IP address that's in the list of RTRs, the map server will return the list of RTRs so that XTR then could encapsulate to one of the 3 RTRs. And it load splits based on a 5-tuple hash across those RTRs, so you have a cluster and can spread the load. If the XTR, okay, I think the other number 4 points to the RTR, but it, oh yeah, that's correct. If EID2 that's sitting behind an XTR that's behind a NAT makes the same sort of request, he gets the same map reply back. It doesn't matter if he's from behind a NAT or not, he gets the same type of reply as the EID3, because the only way he could get packets through the NAT where EID1 is by encapsulating to the RTR 1, 2, and 3. Okay. So both EID2 and EID3 have to encapsulate at red number line 1, okay, and use the services of the RTRs. If a packet comes to, okay, so let's say this packet comes to RTR3, and RTR3 doesn't have a map cache entry for EID1. What it does is it sends a map request to the mapping system. In this case, the mapping system returns just the translated RLOC information because RTR3 is in the list of RTRs, and the map server assumes that he has pierced the hole through the NAT because the XTR sent the info request. So when he simply receives a packet from either the EID2 or EID3, he can encapsulate to TRLOC, which is the translated RLOC, and he has the translated port number from the info request, he says. So he gets that information out of a NAT info cache as well as the mapping, and then knows what the destination address, destination RLOC, and destination UDP port should be in the outer header. So he would he could be able to send. Got a question?
Somebody else has a question. So
Okay.
Albert, go ahead.
Yeah, thanks. So good morning, Dino. So
Good morning.
is there any authentication between the XTR and the RTRs?
There is no authentication, just like there isn't when you're not behind NATs. So you trust the mapping system to give you a set of RLOCs just like you would in any other scenario.
Yeah, but my understanding is that we went through several discussions regarding public internet deployments. And in my view, clearly NAT traversal is super important when you are dealing with mobile nodes, which are on the wild, meaning that RTR should be deployed on the public internet and not deployed, accessible through the public internet. And the fact that there is no authentication means that, and correct me if I'm wrong, that anyone can use it as a sort of a proxy, right? To hide its own IP.
Well, we can authenticate map requests and map register messages by signing them using the ECDCS authentication draft that we put out. So not anybody can get a map reply. EID3 and EID2, if their public keys are in the mapping system and they sign those map requests, that means they're allowed to use this particular EID. And the map servers, which are also map resolvers, verify the signatures in the map request. If they verify, then that means they're allowed, they've authenticated and are part of some kind of access list to be permitted to use those RTRs. So we could use that. And my implementation does support that because I support the authentication regardless of what's being returned to any ITR, if it's behind a NAT or not.
So what the other draft is doing is that and I hope that I recall correctly, is sending the map register through the RTR encapsulated. And then the RTR is looking at the map notify, and we are using the security association between the XTR and the map service and the map server to authenticate the RTR.
Yeah, now you have to put the RTRs as part of the control plane authentication path, and we never had to do that before. So I wanted to stay with the current model where we don't have a third-party hairpin in terms of control plane. RTRs up to now have always done data plane only stuff, and they get all their control information directly from the mapping system as well as all XTRs. So I stayed with that homogeneous model.
Yeah, I understand that. I still see issues when deploying RTRs being accessible through the public internet with no authentication.
Well, I mean, somebody has to ask the question, is LISP going to work on the public internet or not in general? And if you're going to say no because the BIS drafts are saying, pushing back a little bit by saying it's not, then why would the NAT traversal document have to support the public internet? So I think we need to be consistent about that on both ends. So obviously, by using NAT traversal, you're assuming that you have some form of protection, security through obscurity, and that you want to go into public environments. But public environments could also be an enterprise network that's using NAT for whatever reason because of it doesn't have enough IPv4 addresses or whatever, or it's not using private addresses.
Yeah, I need to make a short clarification. So the BIS documents are not saying that LISP cannot work over the public internet, but rather that some mechanism that are specified in LISP must not be deployed when using it over the public internet. But LISP can work over the public internet with LISPsec and so on. But right. I guess that's a larger discussion. So thanks for the answers.
Fabio, go ahead.
Yeah, this is Fabio Maino. I think, Dino, at least you need to document this discussion on the role of security and authentication in the document, because I mean this will be really the first question that our good friends, security reviewers, will bring up.
Yeah, well, it depends on what the fate of this document is. Which kind of brings me to the next slide. So these are some design observations that I can conclude with. So the first point is that the ITR has a very small map cache. Since the ITR behind a NAT virtually runs, I can't read it because it's too small. Hold on a second. Okay, runs no control plane. It has a very simple data plane. All it does is Arlo probe the RTRs in the common set and maintains a very small map cache. So you could put very lightweight devices behind NATs, which we may want to do for cell phones or dash cams or IoT type gateways and devices that we've tried to deploy over the years. So it's nice to have a small map cache. Point number two is that the XTR that's behind the NAT can tell another XTR behind the same set of NAT devices. So by returning private RLOCs in the info reply, you could determine that another XTR is behind the same NAT as you, and then you can actually encapsulate to the local private RLOC, and then you have a shortcut. So that means any packets between two XTRs don't have to hairpin through the NAT to the RTR and back because they're actually at the same site. And that's been proven useful to use more optimal paths. Point number three, if an XTR has a direct path to a LISP site, it could then send directly. And that was the case where this XTR behind a NAT wants to be able to talk to a remote ETR, but since it's not behind a NAT, its RLOC is a global RLOC and doesn't have to traverse a NAT on that side. So you can encapsulate directly to it without having to go to the RTR. The next point,
you have 2 minutes, so just
okay. Yeah, I'm pretty much done. I just have to go through these couple bullets and I'll be done. By sending info requests to map servers, if they're also used as map resolvers, you can use the info request info reply exchange as a simple pinging or keep alive reachability mechanism to know that map resolvers are up. And if you don't get replies, you could time them out and avoid sending map requests to those down map resolvers. I also implemented Lisp crypto through this as well because there's no reason why you can't do a Diffie-Hellman exchange between these global RLOC addresses as you see them locally. So you can encapsulate, encrypt, and then encapsulate packets that go through one or more NATs or NATs on one side and no NATs on the other side. The second to last point is what's really interesting is since the RTRs are the only ones that are keeping the global RLOC information of XTRs behind NATs, as those XTRs move around, which they do in containers in cloud environments or Lisp mobile nodes, when they register their new RLOC because of the movement, only the RTRs have to be updated. So if there's thousands of remote ITRs that are sending EID to this XTR, they keep sending to the RTRs. So that level of indirection helps for scale quite a bit. And the protocol procedures in this document can be used when the list site has multiple XTRs, each connected via separate NAT devices to the public internet. The XTR registers their global RLOCs and can do merge semantics. What the original draft had was each XTR behind separate NATs could register their NAT information unilaterally. And with merge semantics that we added to the mapping system at that time, because of that draft, the mapping system could get multiple translated RLOCs at the same time. So that works quite nicely. Next slide.
Well,
And
Alberto, go ahead.
What's that?
Alberto had a question.
Oh, okay.
Go ahead, Alberto.
Can you guys hear me now?
Yes.
Yeah.
Yes.
Okay, much better. Yeah, Dino, two quick questions. One is, so when the XTR, so an XTR that is behind NAT has a default map cache entry towards the RTRs, right? So when it is going to decide to send a map request, because all the traffic is going to hit that default map cache entry.
You can install more specific routes in the map cache. My implementation, you can install static map cache entries, and the RLOCs that are configured for that is an action that says send map request. So a forwarder would match on the more specific entry, which instructs it to send a map request, rather than using the more coarser entry that has RLOCs.
Right, but yeah, that needs to be a static map cache entry, right? So you need to configure the XTR in that particular way.
Yeah, you did. You configure a set of prefixes that you know that are not behind NATs, and that's easy to do mostly because when you want to talk to server systems that are out in the public, you can configure those prefixes, and those are prefixes of EIDs, so they're the service addresses, not the RLOC addresses.
Okay, and the other question I have is when the XTR moves, your draft assumes that it's going to be still behind the same set of RTRs. Is that correct?
Yes, as long as it registers to the same map servers, which is what the general Lisp architecture wants to do. The answer is yes. Right now, what the original NAT traversal said for future reference is: do you want the map server to give you a different set of RTRs depending where you're moving? If you're moving from, say, one service provider or to another, or a long geographic area, you may want the RTR to be close to the XTR. But arguably, you might want the remote ETRs to be close to the RTRs. But what's most important is you want your set of encapsulators and decapsulators to have the RTRs relatively in the center of gravity, so there's no hairpinning, that they're somewhat en route. And usually that's in where usually those RTRs are deployed in an access provider for either the ITR or ETR on each end. The packets are flowing in those directions.
Dino, sorry to interrupt you guys, but we have to move forward, otherwise we will leave too much time to Victor. Is an interesting discussion. We should anyway take into the list, because the working group has to discuss a little bit on this approach for NAT traversal, the other approach for NAT traversal, and especially look at the security stuff. Okay?
Yes, but my request is not to make this a working group document. That was what the last slide said. I just want to publish it as an informational RFC. So,
okay.
I mean, unless the working group wants to do something different with it. But what the last slide said was, I wanted to get an opinion from the working group if it should be published, if I can publish it as an informational RFC. Now, I know I don't need the working group approval for that, but I'm still asking.
We will discuss this one on the mailing list.
Yeah,
Okay.
but let me just say, if you take it to the ISE and ask to do it published as an individual informational, it will be punted back to us to ask if this is an end run around the working group, and we would probably say, yes, this is an end run. Please hold this off until after we have published the working group NAT traversal.
Okay, so I guess we'll take it to the list on opinions if we should merge the design or keep it separate or whatever. Is there any opinions?
Okay. No, we can't. We don't have time to discuss that right now.
Yeah, let's move forward. Okay. Thank you very much, Dino.
Victor, you have the microphone.
Thanks, guys. So good morning or good evening, wherever you may be. So this is a follow-on on the discussion we had at the intern meeting. We discussed a little bit of the federation requirements, and they weren't quite clear. So hopefully I got a little more context on what the requirements are for federating mapping systems in the Civil Aviation Organization network. If we can go to the next slide, please. So I'm going to do a very quick refresher and focus mainly on the requirements. If time allows, and we may not get there, I'll discuss a potential mechanism that could be used, but it's not complete by any stretch. So let's focus on the requirements. If we go to the next slide, The context of this is that we have basically a worldwide network for aviation. There is air traffic control traffic that is supposed to go over that network, and there's also airline traffic, so airline to aircraft traffic that is supposed to go over the network, and we'll see that that poses different requirements. In a nutshell, we have a series of radio networks, whether that's radio or satellite, and the aircraft connect to different networks either simultaneously. So you can see the bottom aircraft is simultaneously connected to 2 radio services, or it roams between them. And there's the combination of those 2 cases. In any case, the IP network that these radio regions feed into is an IP network where we're proposing the use of LISP. The proposal is captured in the ground-based LISP draft. And the problem at hand here is that ground-based LISP network is running over a substrate that is handled by multiple service providers. As you can see there, you've got service provider A, B, C, and they service different parts of the radio regions. And let's look a little more at how this is supposed to work. If we go to the next slide. So what happens is the aircraft will actually connect to multiples of these regions. And when the aircraft connects to a particular link, it's going to send to the radio region a signal which indicates its preferences for the use of that particular link. And it's done on a per application basis, but we'll get into that in a second. In any case, the metric propagates from the aircraft through the radio regions all the way to what we're calling the air-ground routers. Those air-ground routers are our XTRs. Those XTRs will actually, and I'm going from left to right, by the way, those XTRs, which are in dark blue, those pucks in dark blue, will actually register with the mapping system, and they would register with a set priority and weights that are reflective of the metrics that we're receiving from the aircraft. And that gives us the registration picture that you see on the far right. Then the process is as usual. I do a map request, get a map reply, cache it, and we see how the ground on the right-hand side, the ground facilities that maybe the airline, for example, can actually either spread the traffic across the different radio regions by reaching different XTRs, which are air-ground router 1 and air-ground router 2, or understand that there's been a move. So if we go to the next slide, you'll see that now the aircraft kind of disconnects from radio region 2 and connects to radio region 3. And how that is expressed is by sending lesser metrics on radio region 2 and better metrics on radio region 3, so that the priorities on radio region 2 on AGR2 are now set to 2, and the priority on AGR3 is set to 1. So that basically overrides the use of a air-ground router 2. So that's basically how they're tackling mobility in this particular case. So and this is important because those registrations will be funneled through different service providers in that network, and that's where the impact on the federation comes into play. So just remember that we're going to be getting the information on an EID from different angles, from different service providers, with different priorities and weights. And we need to make a decision on what the consolidated mapping looks like when that happens. So if we go to the next slide, Luigi, please. The other aspect of this is that the registrations are, they can be per prefix, and that's what we're recommending to the Civil Aviation Mobility Work Group, that each application has its own prefix. What they've done is they've assigned a subnet, an IPv6 subnet to each aircraft, and therefore it's conceivable that each application could have its own IP address within that subnet. But there are many proponents of simply tagging the applications with DSCP values. So if we had to use DSCP values, what you see on the screen here is registrations that are specific to an extended EID, which is made of a DSCP value and an IP address. You can see how you've got different priorities and weights for one tuple of IP and DSCP. And in the example, aircraft Y with green DSCP is one application, and that has a preference of going over the air-ground routers on the north side of the slide, and aircraft Y with a red DSCP value, sorry, with a green DSCP value will have a preference for going on the south side of the slide. So there may be extended EIDs that need to be propagated into the Uberlay, and the federation is basically what the implication of this is. If we go to the next slide. Okay, so they have basically a consortium of different providers. Right now, the number is relatively small. There are about 3 or 4, but that is growing. We have proposed the Uberlay model as a way to architect the mixed environment. There is a hierarchy of regions, but there's also a set of peerings between the CSPs. So those peerings are subject to all sorts of regulation and policies and rules, and we need to make sure that we are meeting those rules and that we are able to enforce the policies. So if we go to the next slide, I'll show you in a diagram what I mean by this. So we have here 3 global networks. Some examples of those are CITA and ARIN. Those are 2 of the global networks, and those have presence in different regions. So on if you look at this geographically, on the left side and the right side, we can just say we have a west operation of each CSP and an east operation of each CSP. That's an oversimplification, of course, but the CSPs will also connect to each other on a global basis. They may have more than one peering point. I'm showing a single peering point for simplicity, and this is all their base IP network. We would have the ability to move from the west side of a CSP to the east side of a CSP. We would be able to multi-home to multiple CSPs, so we could connect CSP A and CSP B simultaneously on the west regions, and then roam to the east regions and be also multi-homed. We can move our association between CSP B and CSP C, for example. So all possible combinations are in flight. Now, the way we've suggested we structure this, if we go to the next slide, Luigi, please. The way we suggested we structure this is if we put on top of this LISP network, on the west regions, we are suggesting we use site overlay. So those would have their own XTRs, which are the air-ground routers and the ground-ground routers. It would have its own mapping system, which is that little green puck that you see. I'm focused on the west side right now. So on each blue dotted line, you have a map server assigned to this. So this is the site overlay map server per the Uberlay draft. And then you have a re-encapsulating tunnel router that connects this to the Uberlay, right? So in the Uberlay, each of these regions has a map server presence. And we could have had one map server system per CSP, and then worry about how we federate the map servers amongst the CSPs. But there is an interesting set of requirements that became clear in talking to the civil aviation org personnel further, which was that there may be constraints or policy in which you may opt to not have the East regions have knowledge of everything on the West region, even within a CSP. So in thinking of just a traditional IP network, policies are usually in the form of constraining how much is advertised from one domain to another. This is in some sort of intra-domain filtering, if you may. And then across the CSPs, you're also going to want to constrain what information is shared and what preferences are shared, so that we can actually express some of the requirements for path preference, as well as some of the requirements for localization of activity. So what you see there in the middle is basically a set of map servers that are reflective of the site overlays that are present in the different networks. And the task at hand is to design a model in which they can federate in such a way that we can enforce the policies that are required. If we go to the next slide, Luigi. So this is a potential view of what the federation relationships could look like. So as you see there, within the CSPs, which are the horizontal lines, we have a relationship, and then across CSPs we have relationships. And if you see the way I've drawn this, the relationships between CSPs are drawn as local, meaning I have relationships on the east side between A and B, B and C, and A and C. So I have a full mesh on the east side, but I don't necessarily have to establish a full mesh across regions. This is just hypothetical and an initial reaction to the information gathered so far. These are some of the things that the work group could actually explore. Now, I think as a provider of technology for this, what we would want to do is have a model where those constraints can be implemented. I should be able to have a system where I can implement a full mesh of federation, or constrain it in ways like what we're showing here, right? And the constraint would be in the form of what is registered as well as what is shared and coordinated. So if we go to the next slide, Luigi, I go into go to the next slide. This is just a generalization. We've talked about this about 3 or 4 times. So if we just skip this slide. Okay, so they have mainly three types of traffic. They have air traffic control, which is basically the communication with the towers and the air traffic controllers. This is, and they have what they call—
Victor, just so you know,
Yes.
you've got 2 minutes till the end of the session and 6 minutes now till a hard stop.
Oh, okay. Let me accelerate. So 3 types of traffic: air traffic control, airline operations and communications, and drones, right? So for air traffic control, what happens is the CSPs on the regions need to be informed of everything that is happening with the aircraft. So even though you register with one of the CSPs and you get registered to the CSP Uberlay mapping system, they need to peer with and communicate that information to the other CSPs in the region. So for air traffic control, it's critical that all CSPs are informed, but it's not critical that the east side of the CSP or any of the CSPs have any of the information about that aircraft. So that's one of the requirements. So local peering. If we go to the next slide, for the AOC traffic, which is the airline operations control, the airline may partner with one CSP, and they may, as a policy, not want any of their reachability information to be on other CSPs other than the one chosen, right? So a very different policy for federation here across the different CSPs and also across the regions. So the next slide is basically probably where we should have started. It's like, well, one of the main points of discussion was we need the Civil Aviation Organization is requesting that as the aircraft moves between regions, the registration of the aircraft must move with the aircraft, meaning I can't anchor the aircraft in a particular region. If I move to a different region, we want that to move, that registration to move, so that there is a clear sense of authority and accountability and auditability of where an aircraft is registered. So for many reasons, as the aircraft moves around, it will actually move between different service providers. It would move across countries, even within the same service provider. And for auditability, accountability reasons, the registration of the aircraft is requested to be kept within that country, within the mapping system or the mapping servers that are assigned to that country or to that service provider, so that an audit can actually be completed. There's also limited trust across governments and CSPs, etc. So all of these things that are not technical items, but more administrative items and things that have to do with regulation and audit trails are the main reasons why they're asking us to actually have these EIDs rehome from one map system to another. And if I have one more minute, the next slide is important in this. And I don't know if I have that minute, so
we are over time. I mean,
okay.
You risked it to be cut by me.
Okay.
It's a pity because the topic starts to have a form. Certainly, we need more discussion in the working group and to better understand the problem at hand. But it's really interesting.
Yeah. So what I would say, Luigi and team, is that the requirements are becoming clearer. So maybe it might be an opportunity to write some text and summarize the requirements, and maybe that's one way of actually moving this forward. Or we can have a follow-up on an interim, whichever way you want to do it. I think it would be more conducive to the mailing list to put it in a short document.
We can check on the mailing list whether or not people are interested in an interim meeting focusing on maybe on these requirements, and then to start writing text in order to be clear on what is needed, I think.
Right, and maybe the text could live in the ground-based list draft. Or we could make it, because it's specific to the industry, I think the ground-based list draft might be a place to put that text, versus trying to put the requirements in the Uberlay draft.
Yeah.
That would load it too much, Yeah.
Anyway, I thank you all for the participation. We are really over time. In any second, the meeting can be cut by Mythicos. So we will take it to the list, maybe organize an interim meeting specifically on the Uberlay. Okay? Thank you again, Victor. And thank you all for the participation. See you virtually in Bangkok, maybe.
Hopefully. Thank you, guys.
Stay safe.
Thank you.
Stay safe.
Thanks.
Bye.
Bye.